Good day, students. Welcome to the clip where we're going to be reviewing the law of cosines, sines, and also the area of a triangle using triangle trigonometry. So let's take a look at question number 1. So for number 1, we are to solve the triangle. Solve the triangle with the given measure. And for number 1, what if we have the triangle with angle C is equal to 89 degrees, side A is equal to 8, and side B is equal to 14. Okay, so let's go ahead and draw the triangular situation representing this problem. So let's just draw any arbitrary triangle. All right, and let's label the angular measures. Let's call this angle C, which is 89 degrees, and let's call this angle A. So that'll make this side A, which is 8. Side C, we do not know what it is. Let's call this angle B, and then side B, which is 14. Okay? All right, so to solve a triangle basically means we need to figure out the values of the side lengths or angles that are not given. So big A, big B, and little c. Now, what kind of situation is this? This is an SAS situation. Okay, SAS, side angle side, you're provided with two sides and an included angle, so it's a side angle side situation. If you're solving a triangle using side that is side angle side, you have to use the law of cosines. Okay, the variation of the law of cosines we're going to use here is c squared equals a squared plus b squared minus 2ab cosine c. All right, the reason why we chose this formula is because the problem provided us with big C. Okay, so let's plug in the values of A, B, and big C into the formula that will help us find big C. So what we are trying to find here, we want to find little c. Okay, so finding little c with the law of cosines, we're going to have c squared equals 8 squared plus 14 squared minus 2 times 8 times 14 cosine big C, which is 89 degrees. Okay, so we're going to enter this into our calculators. All right, so let me set my modes to degrees first so that everything is accurate since we're dealing with degrees. Mode in degrees, enter. So we're going to calculate 8 squared plus 14 squared minus 2 times 8 times 14 cosine 89, and our answer is going to be 256.091. Okay, so let's go ahead and write that down. C squared is equal to, was approximately 256.091, and to get c isolated, little c isolated, we'll just take the square root of both sides, root this and root that, and then we'll have little c is going to be approximately, let's enter that into our calculator, that's really close to 16 there. So we're going to do the square root of the answer. So let's just enter that back, close it, enter, 16.0028. All right, so little c is 16.0028. Now let's put the value that we just found back into the triangle so we can know what we're working with. So this side is approximately 16.0028. Now, let's go ahead and find A or B. We can use the law of sines now since we have a complete pair. Okay, so how about we find angle A, find big A. So using the law of sines, we're going to set it up as follows. Since we're looking for big A, we're going to use the following format. We're going to go sine big A over little a. This is the incomplete pair, and then the complete pair is going to be the c's. Sine big C over little c, which is 6. Let's use the variables first. Sine big C over little c. When we apply the value of our measures, we are going to have sine A over little a, which is 8, equals sine big C is 89 over little c, which is 16.0028. To get sine A by itself, we'll multiply both sides by 8. All right, and then we're going to have sine A is approximately, let's put this in our calculator. We'll have sine 89. Well, let's put the 8 there. 8, and in parentheses around that parentheses 8 times sine 89. Divide that by the denominator, which is the answer we got before. Let's just call that back up. Enter. So we have 0.49983. Okay, so sine A is 0.499835. Now to get A by itself, we'll take the inverse sine of both sides. So let's go ahead and do that. So we're going to take the inverse sine of sine A. So inverse sine of sine A is approximately the inverse sine of this decimal value that we got before, 0.49935. This to cancel out, and then we're going to have A is approximately, let's go ahead and compute what the value is. We just take the inverse sine of our answer, and we'll get 29.9891. So angle A is approximately 29.9891. All right, and then last but not the least, we're going to look for angle. We're going to find angle B. Let's go ahead and find big B. Now, in order to find big B, we don't need to use any complicated formula, okay? Because we have two interior angles already, so we can make use of elementary geometry, namely the triangle angle sum theorem. Okay, so let's go ahead and apply that there. To find big B, we're going to use the expression big B is equal to 180 minus the sum of the other two angles, 29.9891 for A plus 89 for C. Okay, so plug that into our calculator to find the value of angle B. So it's going to be, let's work it out, 180 minus, don't forget the parentheses, the answer we got before, plus 89. All right, and our answer will be 61.0109. Okay, so B is approximately 61.0109 degrees. All right, so let's organize all our measures. For the test, I'd like you to round to 3 decimal places. So let's go ahead and do that here. Little c is 16.003. Big A is approximately 29.989 degrees. And big B is approximately 61.010 degrees. Actually 011, because we have to round up. Okay, 011 degrees. And that's the measure of the triangle if it's solved completely. Okay. All right. Now let's go on to question number 2, if I can box this answer. All right, there we go. Let's take a look at question number 2. We're going to be doing the same procedure. We're going to be solving another triangle. So for number 2, what if we have little c equals 18, little b is equal to 17, and little a is equal to 30. Okay, so we're still trying to solve the triangle, just like we did with number 1, solve the triangle. All right, so for this one, let's go ahead and draw a sketch of the situation. So let's draw it like that. Call that side B, call this side C, and call that side A. Okay. All right, let's label the angles. This is angle A, B, C. Big C is little c, 18. Big A, this is little a 30. Big B, this is little b 17. Okay, well, to solve this triangle, basically find the measures of the three interior angles. What type of problem is this? This is an SSS situation, okay? Side, side, side. In order to solve this, we have to use the law of cosines. Since we're not given any angle, we can pick any of the three variations of the law of cosines to use here. Okay, so the variation I'm going to pick is the one that starts with A, because that was the first letter of the alphabet. Nothing really important about that. A squared equals B squared plus C squared minus 2bc cosine big A. Okay, so what will that help me find? That will help me find big A. Okay, all right, let's go ahead and apply this formula to this problem. We're going to have A squared is equal to 17 squared. Actually, we already know what A is. A is 30, right? So let's put that in. So we'll have A squared is 30 squared is equal to 17 squared plus 18 squared minus 2 times 17 times 18 cosine A. All right. To get cosine A isolated, let's subtract 17 squared and 18 squared from both sides. So subtract 17 squared and 18 squared. Using the symmetric property of equality, I can switch this equation around. I'll have negative 2 times 17 times 18 cosine A equals 30 squared minus 17 squared minus 18 squared. Okay, and then we'll divide both sides by the coefficient of cosine A. So divide both sides by negative 2 times 17 times 18. And this by negative 2 times 17 times 18. That cancels out. And then we have cosine A is equal to this expression. Let's evaluate what that expression is with our calculators. So we're going to have parentheses. Don't forget to group your numerator in parentheses. 30 squared minus 17 squared minus 18 squared divided by negative 2 times 17 times 18. Okay, go ahead and do that. Enter. We get negative 287 over 612. Okay, let's go ahead and write that down. It's negative 287 divided by 612. Let's write that again. 287 divided by 612. Now to get big A isolated, what we'll do is we'll take the inverse sign of both sides, okay? So A is basically going to become the inverse cosine of this expression right here, negative 287 over 612. All right, let's plug that into our calculators, see what we get. The inverse cosine of our answer for big A will get 117.966. All right, so angle A is approximately 117.966. All right, let's put that in our triangle. 117.966. Now let's go ahead and find another angle. We can look for angle B next. We can use the law of cosines to find angle B applying the second variation, but this is a long process. There's a simpler formula we can use. Do you know what that formula is? It is a law of sines, okay? We can use the law of sines now because we have a complete pair and an incomplete pair. So what we're going to do next is we're going to find B, okay? So to find B, the formula we're going to use is sine B over little b, the incomplete pair, and the complete pair, sine A over little a, okay? If we apply this formula to this scenario that we have, we'll have sine B that we're looking for over little b, which has a measure of 17, equals sine of A is 117.966 over little a, which is 30. To get sine b by itself, we'll multiply both sides by 17. 17, 17. This 2 cancels out, and we'll have sine b equals, let's plug that expression into our calculator. So we're going to have, in the numerator parenthesis, 17 times sine b, sine, wrong function, times sine b, which is the answer we got before. Let's insert that, close it, divided by 30. Okay, so, okay, I'm missing the parenthesis. Let me see what I did here. Okay, I didn't close my numerator, so let's go ahead and do that. And our answer is going to be 0.500493. Okay, so sine b is 0.500493. So 0.500493. And then to get b by itself, we'll take the inverse sine of both sides. So we have big B equals the inverse sine of this numerical value that we got when we evaluated this expression, which is 0.500493. All right, now to find b, we just use a calculator again to find the inverse sine of that value we got. So let's see, inverse sine of the answer that we got before will tell us the value of angle B, which is 30.0326. 30.0326 degrees. Okay, now we have the second angle. Let's put that in. Angle B is 30.0, see what it is again, 0326. Now to find angle C, we don't need to do much work. We can just use elementary geometry to figure out big C. Okay, so big C is going to be 180 minus the sum of the other two, 117.966 plus 30.0326. Okay, plug that in our calculator to yield the approximate value of angle C. So we're going to do 180 minus parentheses, don't forget that parentheses is really important, 117.966 plus this result here, and your final answer is 32.0014. So big C is 32.0014 degrees. All right, so let's organize all our results and round it to 3 decimal places. Big A is approximately 117.966 degrees. Big C is approximately 32.001, and big B is approximately 30.033 degrees. Okay, so there goes the angular measures of your 3 triangles. All right, now let's move along to question number 3. So we're still doing the same process as we did in the first 2. We're going to solve, we're still solving triangles, so let's solve the triangle. Solve the triangle. Triangle with the measures. With the measures. Let's have big C equals 66 degrees, little b equals 33, and little c equals 32. Okay? Alright, so first thing we're going to do is draw a sketch of the situation. So let's draw the triangle. 66 degrees is angle C. Alright, so let's draw our segments. This is the first segment, this is the second one, and the third segment. Let's call this angle right here angle C. Doesn't really matter how you label it. Angle C, angle B, and angle A. This side is going to be little c, which is 32. This side here is going to be 33. And that's little b. And then this is little a. All right. Angle C is 66 degrees, and we are to solve for our big B, big A, and little a. Now, what kind of triangle is this? What triangular situation are we dealing with here? We're provided with side, side, and angle. Okay, so you can refer to this triangle as SSA or ASS. Whenever you have a situation like this, you are going to use the law of sines because you have a complete pair and an incomplete pair, so you can use the law of sines here. But one thing you want to note about this situation is that this is an ambiguous case, all right? Ambiguous case. What does that mean? It means that when you're solving this triangle, you may have no solutions, no triangular solutions. You can have one triangular solution or two triangular solutions. So you really want to keep that in mind. First thing we can find is angle B. So let's go ahead and find angle B. So to find big B, we're going to use the law of sines. And we're going to go sine big B over little b, since that's what we're looking for, equals the complete pair, sine big C over little c. Okay? Now if we apply this triangle to this formula, we're going to have sine big B over little b, sine little b is 33, equals sine big C is 66, divided by little c, which is 32. Okay? Now let's multiply both sides by 33 to get sine B isolated. So these two cancel out. You have sine B. Sine B is equal to, now let's enter this expression into our calculators. So we're going to have parentheses 33 sine 66 divided by 32. Okay, and then we'll work that out. We get 0.94294. This is good. It doesn't violate the range of sine. So let's write that down. So this sine B is 0.94294. And then to get B, we just take the inverse sine of both sides. So that's going to yield the inverse sine of the result we got before, which is 0.942094. Okay, so angle B is going to be, compute what that is, inverse sine of the result. Insert the answer into the inverse sine function. And we're gonna get 70.4062. Okay, so big B, let's write that down as approximately, let's change that, 70.4062. So big B is approximately 70.4062 degrees. All right, one thing you want to notice, since we're dealing with an ambiguous case here, this angular measure that we just came with is in fact the reference angle. Okay, theta reference. This is the reference angle. There are two angular values of sine that satisfies our triangle. That could be an angle of a triangle and has the sine value of 0.942094. Okay, so what are the two angles that satisfy the measure? Well, since this is a reference angle, we know that the angular values or measures of a triangle can only be positive. So we are going to look at the quadrants where sine is positive and is still within a reasonable value for the angles of a triangle. Okay, so we know that all students take calculus. All students take calculus. These are 4 quadrants. All right, this is 0, 90, 180. So since any angle in a triangle can be between these values, and sine is positive in these two values, so we have 2 possible values for sine. The first one is in quadrant 1. That is what theta reference, the first reference angle. So let's mark that. So this is theta. Theta in this case is equal to B. All right. The next one, the next possible value for sine that satisfies this requirement is in quadrant number 2. Okay, how do we graph that? We just basically graph the reference angle. Remember how you graph the reference angle? The terminal side to the closest x-axis, so this is going to be theta. But the angular value for this b that we're going to be looking for is going to be this angle. Let's use a different color. Is going to be this angle right here. Yeah, that's the angular value. Okay, so this at first theta, let's call that theta 1. That's going to be b1. It's going to be theta 1. And then this is going to be the second angular value that satisfies the triangle. Let's call this theta 2. That's going to be 180 minus theta. Okay, 180 degrees minus theta. Let's write that properly. So that's going to be our b2. It's going to be 180 degrees minus theta. Now, why are we subtracting 180 degrees from theta? We know that this is a reference, angle theta reference. And then to find out what this angle is that can be used to construct a triangle, we just subtract theta reference from 180 because a full angle, a linear pair is 180. Okay? So this angular measure right here will be what our B2 is going to be. All right? So let's write down our results. B1 is simply going to be theta, which is 70.4062. Now, what is B2 going to be? B2 is going to be the supplement of this angle. Is going to be 180 minus theta. All right, which is going to be 180 minus this angular value we got. Let's put that in our calculator. So it's going to be 180 minus this angular value. Enter. And that is 109.594. Okay, so 180 minus 70.4062 is approximately going to be 109.594 degrees. Okay, now that we have two angular values for B, what does that mean? Well, it means that our problem has to be split into two cases, okay? Two cases. And we're going to have two triangular solutions. So for case 1, we're going to have B1 equals 70.4062. We're going to solve that completely, and then we'll shift our attention to case number 2. Okay, so let's split it down the center. So let's draw, we have to draw another triangle so we don't confuse ourselves with labeling the in inserting the right values into our expressions that we create or our formulas. So let's, well, I gotta draw this triangle again. Angle B in this case is less than 90 degrees, so let's draw it accordingly. So something like this, less than 90 degrees. All right, so whatever variables that we find have to have an index of 1. So B1 is going to be 70. Let's put it in green. 70.4062. That's B1. What do we know? We know C, angle C. Angle C is 66 degrees. We also know that little c is 32. Now we need to find big A. We're going to call it A1. And we also know that little b is 33. And we also have to find little a1. Okay? So these are the measures for triangle 1 that we need to find. Let's go ahead and solve this triangle completely. Then we'll go to case 2. Alright, so for case 1, what can we find next? Notice we have two angles. We can use the triangle angle sum theorem to find a1. So let's find a1. So to find a1, we're going to have a1 is equal to 180 minus the sum of the two angles, 66 plus 70.4062. So a1 is going to be approximately, let's plug that into our calculators, it's going to be 180 minus 66 plus 70.4062. What was that? And our answer is going to be 43.5938. Okay, let's write that down. 43.5938. That's our measure for big A1. All right, next thing we have to find is little a1. So to find little a1, we have a lot of complete pairs here. So we can simply use the law of sines. Okay, so we're going to use the law of sines. We're going to use a1 over sine big A1 equals, the complete pair C is a nice one, is what was given to us originally, so that'll be an optimal choice. Little c over sine big C. Okay, so we apply the measures that we have in this triangle to this formula. We're going to have, that implies that little a1 is what we're looking for over sine a1. Sine a1 is 43.5938 equals, little c is 32 over sine big C, which is 66. Okay, to get a1 isolated, we'll multiply both sides by sine 43.59. Let's write this again. All right, I moved it downwards so we don't have an overlapping situation there. Okay, so to get a1 by itself, you multiply both sides by sine 43.5938 on the left side, and also here sine 43.5938. These cancel out, and you get a1 is approximately, plug that in our calculator. We're going to have 32. Let's put that in parentheses, the numerator in parentheses, sine, the answer that we got here, close that, divided by sine 66. And our final answer is going to be 24.1535. Okay, so A1 is 24, approximately 24.1535. Okay, so let's go ahead and organize our answers for the first triangle. So for the first triangle, we have big B1 is approximately 70.4062. Big A1 is approximately 43.5938. And then little a1 is approximately 24.1535. So these are our solutions to the first triangle. All right, now let's shift our attention to the second triangle, case 2. So for case 2, we have big B2 is approximately 109.594. Okay, so let's sketch the triangular situation there. So it's going to look something like this. Like that, and like that. Okay, so now let's populate the measures. You notice that the length of A has changed a little bit. The length of side A has changed, so that's because we're using a different value for our angle B. Okay, so in this case, we're going to have big B2 is going to be 109.594. And now, whatever measure we are looking for, we have to give them an index of 2. Our big and little c's are given in the problem, so they don't have a 2. We have to find A2. We already know B is unchanged. We didn't have to find that. And we have to find little A2. Okay, so compare these two triangles. You can see how we had A1, and B1 for case 1. For case 2, you have A2, B2, and A2. All right? So we're going to solve this triangle in exactly the same fashion that we did here, but our numbers are just going to change slightly. So let's go ahead and find A2. So we're going to use triangle Angleson theorem. A2 is it's an approximation. Because approximately, you add these two and subtract from 180. So 180 minus the sum of these two angles, 109.594 plus 66. Let's plug that into our calculator to find the value of the measure of A2. So we have, let's go ahead and do it, 180 minus, let me see if I can grab the answer I had before. Grab that, plus 66. And the value of A2 is going to be 4.062. 4.4062, okay? So 4.4062. Now what are we going to find next? We're going to look for, what are we going to look for? We're going to look for little a1, little a2, okay? So let's find little a2. Find little a2. Since we have a complete pair and an incomplete pair here, we can use the law of sines as we did over here. So we have a2 over sine a2. And the choices for the complete pair is better to use the c's because they look nice, they're exact. That's what we were provided with in the problem. So that's why I'm going to use the c's, okay? All right, now let's apply this formula to this problem. So we're going to have a2 is what we're looking for over sine a2, sine 4.4062 equals little c, which is 32, over sine big C, which is 66. Now to get a2 isolated, we just simply multiply both sides by sine 4.4062, sine 4.4062. Those two divide out. And then to get a2, we're just going to plug in this expression into our calculator, okay? So let's call that our calculator. Let me change what I had here before. Call that back. Wait a minute. Let's clear this. Call that back. Enter. And I'm going to change my sine argument into my updated sine value, which is 4.4062. Okay? That gives me a value of 2.69112. So A2 is approximately 2. Let's fix that. Let's bring it back. A2 is approximately 2.69112. All right. Let's see. All right. So that's all we have to find. So let's organize our answers into a nice list. Big B2 is approximately 109.594. Big A2 is approximately 4.4062. Remember on the test, 3 decimal places is sufficient, okay? And then A2 is approximately, let's try that again. A2 is approximately 2.691. All right, so there goes your final answer. All right, now let's take a look at question number 4. Question 4, we're to find the area of the given triangle using 2 distinct formulas. Okay, so let's say we have triangle ABC as illustrated here. This side is 16, side B is 16, side A is 15, and side C is 12. Okay, now when I say 2 distinct formulas, you're going to be using the SAS formula. Let's list the formulas you're going to be using here. Formulas. You're going to be using the SAS formula, which is the formula area equals 1/2 AB sine C, or it could be BC sine A or AC sine B. And then you're also going to be using the SSS formula, also known as Hero's formula, which is area equals the square root of S times S minus A times S minus B times S minus C. Okay, where S is a semi-perimeter given by A plus B plus C divided by 2. Okay, so if you take a look at this problem, which of these formulas can we apply directly to this situation? Well, in order to answer that question, we have to determine what kind of situation we're dealing with. We're given side, side, and side. This is an SSS situation, so we're going to use formula 2 first. So let's use formula 2. Formula 2, the SSS formula. And then we're going to shift our attention to formula 1. Okay? So for formula 2, first thing we have to find is the semi-parameter, so we can plug it into the main formula since we already know A, B, and C. So let's find the semi-parameter first. S is equal to A plus B plus C over 2. So if we apply this formula to this situation, we're going to have 15 plus 16 plus 12 over 2. Okay? Now let's plug that into our calculator and see what we get. We'll have 15 parentheses. Whenever you add in or subtracting terms, in the numerator or denominator, you must group them with parentheses or else you have a grouping error in your calculator. So group the entire numerator divided by 2. So 15 plus 16 plus 12 over 2. We use the semi-parameter, which is 21.5. So S is equal to 21.5. Now what do we do next? Now that we have the semi-parameter, we can now proceed to finding the area, okay? So the area is going to be the square root of S, which is 21.5, times S minus A, 21.5 minus 15, times S minus B, 21.5 minus 16, times S minus C, 21.5 minus 12. Okay, we'll enter this entire expression into our calculator. And let's see what we get. That should give us the area. Okay, so let's go ahead and do that. So we're going to have the square root. Be careful with your grouping here so that you are taking the square root of the entire radicand. Okay, so 21.5 times parentheses 21.5 minus 15 times 21.5 minus 16. Okay, let me start this all over again. All right, let's start over. Square root of 21.5 parentheses 21.5 minus 15 times 21.5 minus 16 times 21.5 minus 12, and then that gives us 85.4514. All right, so let's write this down. Our area 4514. Our area is approximately 85.4514. Okay, now that's that with formula 2, which is straightforward. You can use it directly. Now we're going to shift our attention to formula 1. Let's go ahead and find the area of the triangle using formula 1. So formula 1 is the SSS situation. I'm sorry, the SAS. Okay, the SAS situation. Okay, what makes this complex is that we only have 3 sides. In order for us to use this formula, we must determine the value of an angle. Okay, so we want to use 1/2 AB sine C. We can just go ahead and find angle C. Okay, so how can we find angle C? Find big C. This is a problem that's very similar to what we did, I think, in number 2 of this review series, finding the angular measure of an SSS triangle. When you deal with SSS triangles and you want to find missing sides, you have to make use of the law of cosines. Okay, so we're going to use the law of cosines here to find angle C. The one that we are going to be using in this problem is C squared equals A squared plus B squared minus 2AB cosine C. All right, so let's go ahead and populate our measures. We have 12 squared equals 15 squared plus 16 squared minus 2 times AB 15 times 16 cosine big C. All right. Now we're going to do this as we did the other problem. Let's subtract these squared quantities from both sides. So I'm going to subtract 15 square and 16 square from both sides. Subtract 15 square and 16 square. And that's going to yield, and then using the symmetric property of equality, I can write this as negative 2 times 15 times 16 cosine C equals 12 square minus 15 square minus 16 square. All right, so let's divide both sides by the coefficient of cosine C. Divide both sides, we're going to have divide this side by negative 2 times 15 times 16. And this side by negative 2 times 15 times 16. These two divide out. And we'll have cosine C, cosine big C is approximately, now let's enter that expression into our calculators. So we're going to have, let's see, what do we have? 12, parentheses, don't forget to group your numerator in parentheses, 12 square minus 15 square minus 16 square. That entire expression divided by parentheses negative 2 times 15 times 16. Close that. Enter. And then we get 0.702083. Okay, so that's what cosine C is. Let's write that down. Approximately 0.702083. And then to get big C by itself, we'll take the inverse cosine of both sides of the equation. So we're going to have big C equals the inverse cosine of 0.702083. And let's see what that is with our calculators again. So the inverse cosine of our answer is going to be, okay, let me change the modes to degrees. Change the mode to degrees first because I reset my calculator. So change the mode to degrees. Enter, enter, enter. Okay, 45.4056. So big C is approximately 45.4056. Okay, so are we done yet? The answer is no. We want to find the area, right? So the area, using the second formula, we recall, is 1/2 AB sine C. So now we're going to put everything together. So the area is going to be approximately 1/2. A is, let's see, what is A again? A is 15. B is 16. Sine C, sine 45.4056. Alright, so we're going to plug that into our calculator. Alright, so when we plug it in, we're going to have, let's see, 1/2, 1 over 2, 1/2 of 15 times 16 sine of the previous answer we got. Then I'm going to enter 85.4514. So the area is approximately 85.4514. Okay? So since our two answers are the same, we are confident that our area value is in fact correct. Okay, but we can see the power of Hero's formula here. Even though it's ancient, it's really easy to compute the area of a triangle using Hero's formula as opposed to using the much more modern method of the law of cosines and 1/2 AB sine C as a consequence of the development of trig. Okay, so that's that for our review session. And thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel for other cool clips such as this. And please post a comment to let us know what you think about this presentation. More clips can be found on mathgoodserve.com. Thanks again for watching and have a wonderful day.